Lesson 3.4 covers applications of systems of equations. Some application problems can be easily solved using a system of equations. You know to use a system of equations when you have more than one unknown value and you're told more than one fact about these unknowns. The steps to solving a system of equations: Step 1 is always state what the variables represent and be as specific as possible. These are your unknowns, and this is generally what you're asked for in the problem. So a tip is to look at the last sentence and see what the problem is asking you for. Step 2 is find the information you're given about these unknowns, and we're going to use this information to come up with the equations of our system. Then step 3, we're going to solve the system of equations using any method. And finally, step 4, we're going to answer the question that we were asked in the problem. So let's look at the first example. 575 people attended a ball game in which the total ticket sales were $2,575. If adult tickets cost $5 and children's tickets cost $3, how many of each ticket were sold? So first, step 1 is we're going to state what our variables represent. So look at the last sentence. We were asked how many of each ticket were sold. Well, I have two types of tickets. I have adult tickets and children's tickets. So I'm going to let each of these be a different variable. So for step 1, we're going to list our unknowns. We're going to let X be the number of adult tickets and let Y be the number of children's tickets. Now in step 2, I want to come up with my system of equations. Most of the time, if you have two unknowns, you're going to have two equations in your system. So look back through the problem and find two separate things that they told me. What did they tell me about these tickets? The first thing I'm told is the number of people. I'm told that 575 people attended the ball game. Well, if each person attending has a ticket, that means 575 tickets were sold. Well, if X is the number of adult tickets sold and Y is the number of children's tickets sold, if I combine these or if I add these, it should equal 575. So my first equation is X plus Y equals 575. Now look back at the problem and find something else you were told about the tickets. And I was told the money that I took in from the ticket sales. The total amount of money that the tickets brought in was $2,575. Well, adult tickets cost $5 and children's tickets cost $3. If I sold 10 adult tickets, that would be $50. I got that by saying the $5 for each ticket times the 10 tickets sold. So I'm going to take the number of tickets sold and multiply them by the price per ticket. And that's going to tell me how much money I made. So the adult tickets were $5 and I sold X of them, so that's 5X. The children's tickets were $3 and I sold Y, so that's 3Y. If I add the money from the adult tickets plus the money from the children's tickets, that's going to be the $2,575 that I took in. So I'm going to put these two equations together as a system. So I just put a brace in front of them. In step 3, I want to solve this system. Now this is one where I would not want to use the graphing method because my intercepts for the first equation are each going to be at 575, and I don't want to graph that. So the easiest way to solve this system is going to be to use the elimination method. For my x's, I have a 1 and a 5, And for my y's, I have a 1 and a 3. It doesn't matter if you eliminate the x's or the y's. I'm going to do the y's just because the numbers are smaller. So if my second y has a positive 3 for a coefficient, I want the y in my first equation to have a negative 3 for the coefficient. So multiply your first equation by a negative 3. If I multiply by a negative 3, I have negative 3x minus 3y equals negative 1,725. Then rewrite your second equation, which is 5x plus 3y equals 2,575. When I add these, my y's are going to eliminate. So the negative 3x plus 5x gives me 2x. Negative 1,725 plus 2,575 gives me 850. Now solve for x by dividing each side by 2, and I get x equals 425. That means I sold 425 adult tickets. I was asked for the number of each ticket, so I need to find my y. So I'm going to use the first equation, x plus y equals 575, and plug the 425 in for x. Now to solve for y, I subtract 425 from each side, and I get y equals 150. Since y was my number of children's tickets, I know I sold 150 children's tickets. Normally, if I started with a system of equations, I would write my solution as an ordered pair. But since this was an application problem, I want to answer the question and not just give an ordered pair. So to answer the question, there were 425 adult tickets sold and 150 children's tickets sold. The next example, one night a theater sold 150 adult tickets and 100 children's tickets. The theater had $1,050 at the end of that night. The next night there were 200 adult tickets sold and 300 children's tickets sold. The second night the theater took in $1,900. So assuming the cost doesn't change from one night to the next, I want to find the cost of an adult ticket and the cost of a child's ticket. So step 1 is to list our unknowns. What were we asked for? I was asked for the cost of an adult ticket and the cost of a child's ticket. So I'm going to let X be the cost of the adult tickets and let Y be the cost of the children's tickets. Now my second step, I come up with my system. Since I have two unknowns, I want to look back through the problem and find at least two things they told me about those variables. Well, the two things they told me this time were the two different nights that the theater sold the tickets. So night 1, they sold 150 adult tickets. If the adult tickets cost X dollars each, I'm going to multiply the cost by the number sold. And they also sold 100 children's tickets, and the cost of a child's ticket is Y. So I'm going to multiply the 100 by Y. If I add those values together, it'll give me the $1,050 that the theater took in that night. So for night 1, 150X plus 100Y equals 1,050. Then the second night, they sold 200 adult tickets and 300 children's tickets. So this gives me 200X plus 300Y. And if I add these together, that gives me the money they took in for the second night, which was $1,900. These two equations form my system. So step 3, I want to solve the system. 150x plus 100y equals 1050, and 200x plus 300y equals 1900. So if I look at the x's and look at the y's, I'm probably going to eliminate my y's just because it's easier for me to see that the smallest number 100 and 300 will go into is 300. So I want to make my coefficients for each y be 300. Well, I already have the 300 in the second equation and it's positive. So I want to make my first y be a negative 300. So I need to multiply this equation by a negative 3. If I multiply the first equation by a negative 3, I get negative 450x minus 300y equals negative 3,150. And then I'm going to add this to my second equation, which is 200x plus 300y equals 1,900. When I add these, my y's are going to eliminate. So I have negative 450x plus 200x gives me negative 250x. Negative 3,150 plus 1,900 gives me negative 1,250. Now to solve for x, divide each side by negative 250 and I get x equals 5. This time x was the cost of an adult ticket, so the adult tickets cost $5. Since I was asked for the cost of the children's ticket, also I need to plug that 5 in and solve for y. So I'm going to use my first equation, the 150x plus 100y equals 1050. If x is 5, I have 150 times 5 plus 100y equals 1050. 150 times 5 gives me 750. So I begin solving for y by subtracting 750 from each side. When I do this, I get 100y equals 300. Now divide each side by 300 and I get y equals 3. So go back, step 4 is to answer the question. X is the price of an adult ticket and Y is the price of a children's ticket. So the adult tickets cost $5 and the children's tickets cost $3. In the next example, a restaurant manager wants to purchase 200 sets of dishes. One design costs $25 per set and the other design costs $45 per set. If the manager wants to spend exactly $7,400, how many of each set should be bought? So first, begin with your unknowns. I'm asked for the number of each set that should be bought. So let's let X be the number of $25 design sets, and let Y be the number of $45 design sets. So now let's look at our system. I want to find two parts of information, or two types of information that the problem tells me about these sets of dishes. Well, first, the manager wants to purchase 200 sets. If X is the number of $25 sets and Y is the number of $45 sets, if I add the numbers of each sets bought, that should equal 200. So the total number of sets is going to give me the equation X plus Y equals 200. Next, I'm told the amount of money the manager wants to spend. So let's look at the cost. If the $25 set costs $25 per set, I'm going to multiply the 25 times X, the number sold, to find out how much money I'm spending on those sets. I'm going to do the same with the $45 set. I'm going to take Y, which is the number sold, and multiply it by $45 to determine how much money I'm spending on the $45 sets. If I add these together, I'll get the $7,400 that the manager wants to spend. So my second equation is 25x plus 45y equals 7,400. If I put these equations together, this gives me my system. So step 3, I want to solve this system. So I want to eliminate either one of my variables. I'm going to eliminate the x's just because the numbers are smaller. My second x is a 25, so I want the x in my first equation to be a negative 25. I can get this by multiplying the entire equation by negative 25. If I multiply that first equation by negative 25, I get negative 25x minus 25y equals negative 5,000. Then rewrite your second equation, 25x plus 45y equals 7,400. Now if I add these equations together, my x's will eliminate. And negative 25y plus 45y gives me 20y. And negative 5,000 plus 7,400 gives me 2,400. If I divide each side by 20, I end up with y equals 120. Now I want to plug that into either equation to find my x. So if I use x plus y equals 200, replace the y with 120, I get x plus 120 equals 200. Now subtract 120 from each side and I get x equals 80. So if you look back at your unknowns, x was the number of $25 dish sets that I buy, and y is the number of $45 dish sets bought. So to answer the question, the manager should buy 80 sets of the $25 design and 120 sets of the $45 design. Now for our final example, one group of people purchased 10 hot dogs and 5 soft drinks at a cost of $12.50. A second group of people purchased 7 hot dogs and 4 soft drinks at a cost of $9. And then I'm asked, what is the cost of a single hot dog and what is the cost of a single soft drink? So first, let's list our unknowns. I'm asked for the cost of a hot dog and the cost of a soft drink. So I'm going to let x be the cost of a hot dog and let y be the cost of a soft drink. Next, I want to set up my system. So look for 2 different things that you're told about the price for the hot dog and the soft drink. Well, I'm told the purchase that 2 different groups make. So I'm going to let each group's purchase be an equation. So let's look at group 1. They purchased 10 hot dogs and 5 soft drinks. Well, hot dogs cost X dollars and soft drinks cost Y dollars. So to find the amount of money they spent, I'm going to multiply the X by the 10 and the Y by the 5. So I get 10x plus 5y. This is going to equal the money that they spent, which was $12.50. Now look at group 2. They purchased 7 hot dogs and 4 soft drinks at a cost of $9. So for their purchase, you say 7x plus 4y equals 9. These 2 equations are going to give me my system. So I want to solve this system of equations. I can eliminate either variable. I'm going to choose to eliminate the y's. With the 5 and the 4, my least common multiple of those would be a 20. So the smallest number that 5 and 4 will go into is a 20. So to get a 20, I'm going to multiply the first equation by a -4 and the second equation by a +5. That will give me my opposite signs. So if I multiply the first equation by a -4, I get -40x minus 20y equals -50. If I multiply the second equation by a +5, I get 35x plus 20y equals 45. Now if I add these equations together, -40x plus 35x gives me -5x. My y's are going to eliminate, and -50 plus 45 gives me -5. Now I can solve for x by dividing each side by -5, and I get x equals -1. X was the cost of a hot dog, so I know the hot dogs are going to cost $1. I was also asked for the cost of a soft drink, so I want to plug this back into either equation to find my y. So I'm going to use the 10x plus 5y equals 1250. If x is 1, I have 10 times 1, which gives me 10 plus 5y equals 1250. Now subtract 10 from each side, and I get 5y equals 250. And if I divide each side by 5, I get y equals 0.5 or 50 cents. So in step 4, to answer the question, each hot dog will cost $1 and each soft drink will cost 50 cents.